Gracias. Thank you for having me today. I'm going to give a talk broadly descriptive of forestry in my little corner of the United States and some of the challenges we currently face. One of my previous professors, the late Professor David Smith, used to say that all foresters are very good at managing the forests that the previous generation of foresters encountered. And I feel very much the truth of his words now as I face some of the challenges, as we see some of the difficulties that we face in our particular region of the United States. So I'll give you an overview and then try to touch on some of the issues that we are currently facing. So again, a brief history and description of our area. I'm going to talk about one of our species. We have nearly 100 species of trees in our forests. So right away you can imagine that our forest management is potentially very complex. I'll pick one species to illustrate some of the challenges and then speak more broadly about some of the challenges and opportunities that we face. In the US now, it's unpopular to speak of problems. Everything's an opportunity, right? So we have many opportunities in forestry. So where are we in particular? Here's the continental United States. Alaska's somewhere up there. Hawaii's over there. We never put them on our maps. New England is this corner right here. There are 7 states. For geography, for those for whom it helps, New York City is right here, Boston is right there, Washington, D.C. is right about there. So it's really the far northeastern corner of the United States. Of course, we have Canada up here, but they're different as well, and we don't usually put them on our maps either. So some quick facts about this region. It's formed of 6 states. Several of them were among the original English colonies, hence the name New England. So Connecticut, Rhode Island, Massachusetts, Vermont, New Hampshire, and Maine. So I'm from the University of New Hampshire. That is what it is. It's about nearly 200,000 square kilometers. About 15 million people live there. So depending on your perspective, that's either very densely settled or not. Actually, there's a very strong gradient, as we'll see, of population density, and that influences our management. It's also a very heavily forested area. My state, New Hampshire and Maine, we always battle to see in the latest statistics which state is the most heavily forested in the country. Both of those states are nearly 80% forest cover. So farther south in the region, it's less so. One of the things that is characteristic of our region and of the US in general that is very different from many other countries is that our control on land use and on forest practices, to put it politely, is decentralized. And in our region, nearly all of this forest land, the vast majority, is privately held by a very large number of private landowners. There are some large private holdings. There are a few large public holdings, but mostly we're talking about privately held land, some large investment ownerships, but many, 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 many individual private landowners. That has a lot to do with some of the challenges we'll talk about here. But forests have always been important. This is a flag that was flown by ships in our colonial era in the 1600s. And we've got a pine tree right there in the corner. Very important. Climatically, the region is very humid. Right now, the temperatures outside are the same as here, only the water at my house, or the air at my house, you can drink it. It's probably 80% humidity in the summer. Our precipitation is abundant and well distributed through the whole year. There's no dry season. It's, we have 4 seasons. We have winter. After winter comes mud season. After mud season comes the summer, which can be divided loosely into black fly season, mosquito season, and then a very brief, pleasant period before fall, which I think is the most beautiful and enjoyable time of year if you want to come visit New England. You won't be alone. Many people come to New England for the fall foliage. Very strong influence of the ocean on our climate and on our culture, and very beautiful forests, well distributed and very accessible to the public. So here's a little chart of the region, and just to be kind, I've tacked on the state of New York. Often, it's sometimes useful to talk about New England and New York, and well, they're in this graph. So here's a graph showing the abundance of forest cover in the region. Again, Boston is here, New York City is here. So you can see in the Boston and New York area, forest cover is low because there's a lot of pavement. Elsewhere, very high levels of forest cover, in some small areas, 90% and greater. So in terms of our public ownerships, in fact, that's where we see 90%. So these are the Adirondack forests, the Catskills, the Green Mountain National Forest, and the White Mountain National Forest. But that's about all the large public forest land there is. The rest of this is private. A lot of agriculture in a few isolated areas, but forests are the dominant cover of the region. Well, why is that? I think it's useful to take a very long view of history. That's not characteristic in the US. Usually our view of history is what happened last week. But I don't think you can understand our region without taking a long view. The glaciers really gave us what we have. You know, it's only been 13,000 years since they left, and in most of our region, they didn't leave us much. At my house, if I want to plant a tree, I've got 50 centimeters of soil before I hit bedrock on most of my property. This is not much to work with. Really good blueberries. There are areas that have soil, but all of our soils are glacially derived. They're either tills or some form of outwash. And that has a tremendous influence on what we can do. Notwithstanding that, before European contact, the area was widely settled. We don't know exactly what the indigenous population was in, say, 1400, but there were people there with a gradient of settlement pattern that reflected some of our soil and climatic variability within the region. In particular, in the southern part of the region and along the coast, there were agricultural societies, shifting cultivation, a lot of maize, and also a lot of use of food from the sea. In the north and in the interior, more mobile land use, very heavily driven by hunting. There are controversies in forestry across North America as we look to try and understand what our silviculture should be. And we often look backwards and want to talk about pre-European forest conditions as a reference point. I take great issue with some of my colleagues who insist on calling these pre-European conditions pre-settlement. I think that's a very ethnocentric view, because clearly I think the pre-settlement condition of New England forests is ice. We think there have been people there for a long time, and they did have an influence on forest communities, some of which we can still see traces of today. But it's been about 500 years since European contact. We know there were European fishermen along the coast intermittently through probably the 16th century, if not before. And certainly the first detailed exploration of coastal regions was in 1604. And one of the reasons we think there was an abundant population here is that Samuel de Champlain insisted our part of North America was too densely settled to establish a colony. So he went back up north where it was too cold to Canada, what became Canada. That's what he saw in 1604. By 1620, when the Plymouth colony, the English pilgrims, showed up. We don't teach this part in our schools to children, but the first thing they did when they got off the boat was to get down on their knees and thank God for having cleared this wonderful village site of the heathens who had in fact died the previous year of a plague, probably from contact with European fishermen. So there's a good quote by the ecologist Gordon Whitney. It says, "The Europeans in New England encountered a land that was not so much virgin as widowed." And I think that's very true. The human influence had changed. We don't have records of pre-contact forests. Very quickly, European settlement expanded. It was not a peaceful time. By 1776, these upstarts decided they should declare independence from the King of England, and did so. And the expansion of land use continued until agriculture peaked broadly in the period of 1840 to 1880. I mean, one of my earlier slides, I said our forest cover is as much as 80% in New England. In this time period, flip that. 80% agriculture, 20% forest, and of course the remaining forest was very heavily used. There are very few old growth forests left in New England. In that sense, it's similar to Europe. Our land has been heavily used, not for as long, but very intensively. This period ended for two real reasons. First, the American Civil War took a large fraction of the next generation of farmers. They didn't come back to the farm. And the ones who did realized, wait a second, there's another part of this continent where they have soil. I should go there and grow things. So what's left is a landscape full of stone walls through the forest. Because my house has those stone walls. Many of the rural areas of New England are only now passing the population that they had during this period. There was a decline and then an increase. The 20th century brought continued changes. We had the development in northern New England of a very significant pulp and paper industry that still drives cultural perceptions of what our forests should be and how we should use them. This is an image of the paper mill in Berlin, New Hampshire, from the 1920s. And at one time, this mill and another about 80 kilometers away would rival each other to be the first and second largest paper mills in the world. Both of those mills are now closed. But this was the story of the 20th century. On a lot of that abandoned agricultural land, we had a resurgence of pine forests, the species I'll talk about in a minute. Huge, extensive areas of largely single cohort, even-aged eastern white pine forest. That was the norm. And in fact, in the first part of the 20th century, the early silviculturists in the Northeast, because that's also about 1905, we have the establishment of the first forestry schools in the country. And they would say, yeah, you should grow pine. All these hardwoods are worthless. That changed. Later in the 20th century, we realized, wait, those hardwoods are pretty good. And actually, then we started, how come we spent so much time trying to get rid of them? The other event that we have is the establishment of those large public lands in response to the terrible condition of the forested land at the turn of the 20th century. So the 20th century was a period of change. Most of our foresters, people like me, were trained in this century. And when I think about the challenges and the things that happen here, I'd say really our problem in forestry is to do a good job of growing trees on a sustainable basis to feed these pulp and paper mills and to provide good saw logs to support our sawmills and to support rural communities this is a very straightforward undertaking, and we'll use the tools that we borrowed from European forestry to do it, because they're the only tools that we had. Well, things are changing, and so I'd like to give you a picture of this one species out of 100. I didn't pick it at random. White pine, I'll call it a signature species. I wouldn't call it an ecological keystone species, but it's an important species to us for the region for multiple purposes. First of all, economically, it's always been an important tree in terms of just as wood products, primarily for saw timber, although early on you'd find that back in the colonial period, one of the grievances that caused the colonists to tell good old King George to go away was that the kings of England reserved all the white pine trees bigger than 24 inches, 60 centimeters, as mast trees for the Royal Navy. This upset the colonists to no end. All these trees were marked in the forest with the king's broad arrow, and it was forbidden to cut them. You will find in many houses of the period boards that are 23 inches wide. Surely none of those were cut from trees that were 24 inches and larger. Okay. But it's long been an important tree for us. Ecologically, it's important. It is one of our longer-lived species, and it is one that can provide a great deal of structure for wildlife. Also, the seeds and the cones are masts that are important. And culturally, it's important. I mean, we see it everywhere. It's the state tree of Maine. It's a tree we should have. Right? And there's a lot of it. You can't quite see it in this picture. There's some. We see it now mostly in mixed stands, and I'll show some actual data on that. But it is abundant in the region, I'd say due to 3 factors. One is soils, glacial outwash soils, sand, gravel, nutrient-poor, droughty soils. Eastern white pine is relatively competitive. Those aren't the best soils for pine. Of course not. It's a plant. Nothing likes to grow in pure sand, but it outcompetes the hardwoods there. So those are the soils where we still see pure stands of pine, where it's most easy to regenerate pure stands of pine. We also see it because of land use history. Even on our upland till soils, which were covered with pine and now have much more hardwood, there's still a stronger pine component than there perhaps would be otherwise, because it was there, because there was seed source, and it's fading slowly on the landscape. And finally, disturbance. It's a species that requires some disturbance to regenerate, and we have had some disturbances that have allowed the regeneration of pine. However, I'm going to show you that the picture for this species is not great. One factor is that there are multiple forest health threats. We've had white pine blister rust, Cronartium. We've gotten rid of that, mostly. But now we have a new fungus, a Caliciopsis canker, that's just been isolated and identified correctly. We've got other things going on with this species, and so disease makes us nervous about the future. And so the question is, can we sustain white pine as part of our forests into the future? Well, luckily, I have, in forestry as elsewhere in science, in English we say we stand on the shoulders of giants. I have people who have gone before me, particularly my colleague Bill Leake, who has now been working for our U.S. Forest Service for 60 years. They have to invent new pins to give him every 5 years because they've never given I don't know what they'll do when he gets to 65 years of service. But about 20 years ago, Bill Leake and some of his colleagues wrote a paper asking these same questions. So I thought it would be useful to go and see if the story is still the same. A great deal of my career seems to be putting numbers on things that Bill Leak already knew. So that's my job. All right, so what did they decide 20 years ago? Well, using inventory data, they said, you know, pine grows pretty well across the whole region. Growth is more than mortality and removals. This is good. But there's not a lot of seedlings, saplings, stands of trees. Not nearly enough to sustain the forest type. If you look at individual trees, oh, the diameter distribution looks good. There's a classic reverse J shape here, so that's good for sustainability. But if this is true, it must be, they didn't have the ability at that time, the computing, whatever. But, you know, interesting that many of these smaller stems must be in mixed stands and they might be in bad positions. So we should really start looking at paying more attention to regeneration and to release of the existing small trees. Okay, were they right? Well, I'm a numbers person, I'm a biometrician. When I go look at data, see what we can find out. Here's the story for growth, mortality, and removals. And if we look at cubic volume, this bar is bigger than this bar. That's not supposed to be the way it is, at least not as a first answer. Actually, I can make this bar a little bit bigger than this bar if instead of using cubic volume, cubic meters per hectare, if I use this horrible so-called unit that we like to use in the United States called the board foot. Because that tips the balance between large trees and small trees, and it makes this bar, oh, slightly bigger than this bar. I say, yay, everything's good. Still, okay, let's just call this approximately equal for now. But this is growing, you know, this is not good. This is a little tight, okay? One of the things I decided to look at was to break out the data and look at sort of the purity of eastern white pine. And to do that, we've developed a relative density measure for mixed species in the Northeast that a couple of you have been forced to read that paper. It's like Reineke's stand density index, but adapted to mixed species. So I use the fraction of the density of a stand in eastern white pine versus everything else to examine purity. And if you're smart, you'll quickly realize these numbers don't add up to 100. Only 33% of our inventory plots have eastern white pine. 67% would be right here on the 0. So only about 3% of our inventory plots are in stands that the majority of the stocking is white pine. Only 8% are in stands where it's 20 to 50%. The vast majority of the stands where pine occurs, it's a fairly small component of the overall stocking. That's very different from the landscape even 50 years ago, when there were still extensive stands of nearly pure white pine. The good news, again, a biometrician, I can spin the data a little bit. If we ask where is the pine volume, there's more volume in a fairly pure stand. And of course, there's no volume in all those stands that were on the 0 line. So if I ask where is the pine volume that's out there, it's a little bit more evenly distributed. And what we find is that, in fact, there's an appreciable amount of the pine volume that's out there is still in these fairly pure stands. And even more in stands where pine is not a majority of the stocking, but it's an important stand component. Okay. The good news for me, on which side of my brain is silviculture, I forget, is that it does mean that to manage pine, I don't have to manage the whole landscape. I can focus my effort on, there are stands that have a lot of pine in them, and we can focus on trying to bring those stands along to sustain the volume. But if we look at the size distribution of stands, and we use these same categories that I had previously. We call these majority, minority, trace of pine. If we look at size distribution, we see something very curious. Stands certainly do not follow a reverse J distribution here. And those stands that have more pine tend to be larger. Now, maybe that's because pine grows fast. In fact, that's part of the answer. But that doesn't explain this hump. If we look at age distribution, and I could spend an entire seminar trying to explain how our national inventory describes stand age. Let's just call this stand age and be happy with it. That doesn't look good, does it? New England, even if we look at all this, New England has a very middle-aged forest. We have no grandparents. We have no children. Very few children. Maybe a few teenagers. But if we look at the stands that are in the most heavily stocked, there are not even as many teenagers. This doesn't look good to me. This suggests we've got a real problem here. I'll speculate as to the causes of that problem here quickly. So, implications. Yeah, Bill Leake was right, except that I think we're now nearly in balance. This is actually frightening to me because when we look at our national inventory data, it's very difficult to take out lands where harvest is not possible. So we're very nearly in balance looking at the whole landscape, but there are lands that will never be harvested. And it's definitely true. We simply don't have small pine stands. We just don't. Okay. Well, let's go back to trees. Okay, pine is in mixed species forests, right? So maybe we don't need pine stands. We just need pine trees. Well, here's our diameter distribution for trees, and if we ignore this annoying thing, this is a reverse J. What could be wrong with that? Everything, should be sustainable. Well, maybe not. But if we do the classic trick, if we log transform this axis, in the US we're very obsessed with the exponential distribution. Things should really be reverse J. And this should be a straight line, and ignore that bump. That's nearly a straight line, okay? This is good. Well, let's break those trees out in each diameter class and ask what is their competitive position. So I've used that relative density measure that I described before, and without going into a whole lot of discussion, let's call this red category. I've asked what's the relative density of larger trees? Those of you who have played with prognosis, Alstage's model, or its derivatives, like to use basal area of larger trees. We're just using relative density of larger trees. Red trees here are dominant or codominant. Blue trees, intermediate, suppressed. Green trees, it's a miracle they're still alive. Eastern white pine does not respond quickly to release. So these blue and green trees are not going to be easy to suddenly wake up and cause to grow. And in fact, especially if you consider there's hardly any trees down here at all, our small trees are largely not in good condition competitively. This does not bode well for the future either, notwithstanding that we have a lot of these. They're not where we want them to be. The reason this matters, of course, growth and survival. Here's an average growth curve for the region. We've all seen the Nature paper about how big trees grow fast. It's great. Big trees grow fast. Well, this is a bit misleading curve. Let's take this curve and break it out by those 3 competitive classes. Okay, this isn't really a line. This is a non-parametric curve. I tried so hard to find a technique that would make this line not flat. And by doing so, I created a tremendous wiggle in this middle class. A dominant pine tree can sustain diameter growth. The problem is these trees are mostly not dominant, so that's why this previous curve is doing this. In other words, the growth in our smaller trees is not what it should be to catch up and fill in. Now, this line does not include site quality. So many things are not here. This is just a typical growth rate. But our population of trees is not doing what it should. Well, so yeah, we still have this roughly J-shaped distribution, but I'm going to argue that's not enough. Bill Leaks and his colleagues speculated that some of these trees must be in the understory or in small gaps. Yeah, they're there. This does not bode well for that next group of trees. And so yes, regeneration and release, if anything, are only more important. And what the data show is that over the last 20 years, we have not addressed that in the field. Well, why not? Is it because we're stupid and we don't know how to grow a pine tree? No, pine trees are easy to grow. In our region, we can get abundant natural regeneration in a seed tree or shelter wood, or even in a clear cut, but then we have problems with weevil. But we can do this. Unfortunately, we tend to tackle these complex stands using single tree selection, which does not promote pine. That may be part of the problem. Of course, part of the problem isn't our fault at all. It's the soils. We can't change our soils. We should expect pine to be fading somewhat on the landscape. But here's the bad part. If I put up the species that do compete well on those till soils, red oak, black oak, yellow birch, sugar maple. Sugar maple's a little noisier. But many of our high-value hardwoods, some of those graphs would look exactly the same. This suggests we have a broader problem. And maybe the problem isn't the trees. Okay. So, what's going on? I think this is part of our challenge. There's just a lot of people outside of northern New England, and people are uncomfortable with cutting trees, certainly making big patches, which is what a disturbance-dependent species like pine does best in. Okay? This is people who are uncomfortable with things, so they're even uncomfortable with making big holes up here. But in fact, if we look at parcel sizes, all of these people live somewhere. And in fact, many of these people, an increasing number of them, have summer and vacation homes up here. This is what parcelization does to our landscape. I apologize, this figure is in acres. 10 acres is about 4 hectares, and many of our foresters would say, below that size, we can't even manage it. Okay? So much of this area, the majority of our forest land is already in parcels that are too small even to do a harvest. If I made this cutoff larger, let's say 20 hectares, which might be a size for which you could write a long-term management plan and think about sustainability, even more of this map falls below the threshold. We're doing this to ourselves. We're chopping our forest into little bits and then saying, we don't really want to cut any trees here, do we? So it's no wonder we don't see young trees coming along. Now, we also, when we do that, tend to grab the large trees conveniently, so we also don't see, I say we have no children, we're also not making more grandparents. So, it's all over. No. It's not that bad. I think we do have some things. First of all, in our region, we need to recognize reality. It's very easy to buy into this idea that, well, forestry is this permanent conveyor belt of trees. No, forests are a product of history. And we have to manage the forests that we have and give the next generation something worthwhile. But what we have isn't what we're going to have, and there's only so much we can do about that. Yeah, we expect pine to fade on the landscape. It's not a surprise. Of course, at some point, growth will fall behind harvest, and hopefully, then later they'll come back into balance. For that to happen, we do still need to think about growing pine trees. We have opportunities to manage stress related to these new health threats. And we need to think about putting some more big trees back on the landscape. Think about that diameter distribution. The King of England would have had nothing to reserve now. We don't have big trees, not like we did. If we look at the bigger picture, not just pine, yeah, we've got this, we have an even-aged forest for all intents and purposes. And it's a forest that we're putting in smaller and smaller pieces. Forestry in New England is going to have to adapt to that. I can't tell you how many invasive insects and fungi we're facing right now. It's a great time to be a forest pathologist. If I were to start over and I wanted job security, I would go into forest pathology because there's so much work to do. At the same time, notwithstanding the challenges, we need good silviculture. We're only going to get out of this and move forward to the future if we apply more brain power in the forest. But the 21st century is not the 20th century. This is a short list of what's in the news in the region. We used to think of that northern land as industrial. Now it's held by insurance companies with a long-term investment horizon, 10 years. Well, if a sawlog rotation in our forests is 80 years, what's 10 years really? There are a lot of concerns about what this means. And if I were one of those companies, I'd be very concerned. In general, the United States is not a good place to make things anymore, and that's nowhere more apparent than in our pulp and paper industry. 40% of the pulp and paper capacity in Maine has closed in the last 5 years. The demand for small, crummy trees is going away, but we need that demand to grow the big, valuable trees. So bioenergy will save us all. Maybe. Maybe not. Europe needs to buy more pellets from us, we say. Maybe, maybe not. But the big pictures, I'm a forester. I have no capacity to, these big changes in populations and what people want. We're also an even-aged population. We have our baby boom, the generation that was born right after World War II, when all the soldiers came home. They're retiring now. They're moving around. What does that mean for our forests? I think that's one of our biggest questions. I bet that right after our presidential election, but before President Obama has left office, you will see in the news, well, it won't make the news here. It's very controversial at home. I think we're going to see a small new national park created in our North Woods. Maybe not. But a lot of people see this as a great opportunity for diversification. A lot of people see this as a threat right at their core. Taking land out of production, locking it up. This is terrible. We'll see. Oh, then there's the stuff that as a silviculturist I'm trained to think about. Okay, climate change, ecology and invasive species, and I think these things are probably going to matter. These will be the second decimal place. These things drive the first decimal place. I don't know. We'll find out. Somebody will find out. The current generation of students will find out. I'll retire in a couple of decades and give you all a bunch of problems. I should acknowledge my sources of funding, our agricultural experiment station. Some of the work on parcelization has been done with colleagues through a research cooperative in our northeastern states. One of the nice things about my university, they very much encourage interdisciplinary work. Professor Ken Johnson is a human demographer. I learn so much every time I talk to him about things that I say, oh, that's going to be more important for forestry than my little change to our yield curve. And Ethan Belair, who's a scientist in my lab, and my colleague, Dr. Bill Leake at the U.S. Forest Service. So thank you, and if there's time, I'll be happy to take any questions. Yes, co-op. Yeah. There is. There are two changes that I think may help. For a long time in the U.S., people have looked to Europe and said, but in Europe they have landowner cooperatives or ways for landowners to work together and manage their land together. That hasn't caught on in the U.S., I think for three reasons. One is that 50 years ago, the need was not so great. One is a legal reason. There are peculiarities in our antitrust laws that stop corporations from working together in smoky, dark rooms to do back deals. And some of those same things could be applied to small landowners. Well, if landowners cooperate, are they fixing prices against the large industrial monopoly that controls the mill? We wouldn't want to victimize them through collaboration. There's a third reason. I think those are, the third is cultural. I mean, the US, you've seen the movies, right? We're a bunch of cowboys. We don't play well with anybody, especially not our neighbors. It's hard. It's more of an uphill battle, but I think we're seeing that. The other thing that's coming into play in a large fraction of the region, we've seen a huge increase in the private land conservancy movement. So small, non-governmental organizations, community-based, buying up some of the remaining large parcels or buying conservation easements, buying the development rights on farm and forest land. And many of those conservation organizations, in fact, see the value in timber management for a variety of purposes. So there's a lot of interest in that, and through that, that may help. But I think those are exactly the kinds of changes we've got to get around. The other thing that we may need to think about, well, somebody will realize there's an opportunity. In our region, we tend to do forestry with big machines that are very expensive, that need a lot of wood to justify picking them up and moving them from place to place. It will probably be more culturally acceptable and more economically practical to work in these smaller woodlots with appropriately sized machinery. Whether that means it'll happen or not, I don't know, but that'll be a shift in the logging side of the industry that needs to happen. The problem is that if you're a young person who's good with equipment and likes to work outside, right now you can make much more money in the construction industry driving a bulldozer than using a chainsaw and driving a tractor. We'll see. But I think all of those things will likely change. People are talking about boutique forestry. We'll see. We'll see.
talking about disturbances, these health threats. Have you or any of your colleagues found any relationship with these health threats and the structure of the white pine stands in terms of purity, in terms of age, diameter?
For white pine, the threat that we're most focused on right now is this Caliciopsis canker. It's a bark canker. At first it was mistaken for blister rust, but we realized, wait, this isn't the same. So mostly we see it affecting stands with a lot of pine in them. So those pure stands are stands with 30, 40% or more. So that's alarming. But as we've begun to look more closely, and I would call out work mostly by my colleagues with the Forest Service who are really focusing on this, we're finding stands that are too dense. Trees are very stressed. Also, the transmission of the fungus tends to rain down from the top. It attacks trees often very high up, but then it will move down. So the trees in intermediate and suppressed positions not only are more stressed, they also experience more propagules. And so what we think will help is to get into these stands and be much more aggressive with our thinning practices, heavy thinning from below, but also some crown thinning to give the dominant trees just more capacity for resistance. We think we've seen some promising early results in some observational work. Again, that kind of silviculture is a bit more visually obvious than gently going in. Honestly, some of what we call silviculture in our region is badly disguised high grading, plucking out the most valuable trees. That looks great to the public, but has not served our forests well. And so that we will see. But in addition to pine, we have emerald ash borer, we have Asian longhorn beetle, which will gladly eat all of our maple trees, or acer. Someday we'll discover we have sudden oak death, Phytophthora. That will show up. I mean, we already have beech bark disease, Nectria, and the joke about beech bark disease in the Northeast U.S. is it's a shame it's not fatal, because our beech is not a high-value species. It wasn't before. And when you disfigure it, it's even less so. So we have many, many, many forest health threats. Really, it's hard to think of a species that isn't potentially about to be eaten by something. And I think that's going to become a bigger and bigger challenge for our foresters, is more just reactive, I would like to think proactive management to try and get in front of forest health problems and keep forests healthy and adaptable. So we know we'll have climate change to deal with as well.
I was thinking about, you said that in the beginning of the last century, you had two big pulp and paper mills.
There were many, but those two were very large, yes.
But now you have others. You have other mills.
Yeah.
And how about, I'm just guessing, if you have, because the industry usually put everybody together in order to be sustainable. Is it going on, or how is it going?
Less so. If we rewind 50 years, there were many pulp and paper mills, there was more industrial ownership, and there were a couple of cooperative research organizations. But those two pulp mills have closed, so have many others. And the companies that owned the mills have sold the land. So they say, okay, but the new owners, insurance companies, hedge funds, lots of kinds of owners. They own the land. Surely they will band together. Their investment horizon is 5 to 10 years. How long does it take a research project to bear fruit, to create information that you can act on? 5 years? 10? Some of those landowners have still been good partners in research, but there's a fear that that'll be one of the consequences, that those large private owners will get out of the research business entirely. There are a few private, still, I'd say, family-held large ownerships that we think have a longer view, but we will see. We will see. Historically, in the U.S. in general, both our large and small private landowners have counted on the national government, our Forest Service research, competitive grants to universities. This will be somebody else's responsibility. And so as some of those players have departed the scene, it's been difficult. It's been difficult to reorient our research enterprise to address some of the new challenges. If we were in the southeast U.S., I would say the situation is different because the manufacturing industry is still stronger there. And so for loblolly pine, for example, we still see some of those old collaborative research enterprises are still very strong. They've changed, they've often internationalized, but they're still going strong. In the Northeast, we're struggling to maintain those.
Because they should have been a kind of management and not only research institutes.
Yes. Yeah.
A management institutes like this, to manage their production together.
I agree. Again, somewhat less of that cultural history of cooperation, but again, the changes in ownership, I think, are having significant consequences for how we think about, who's at the table, who are the stakeholders, and some of the new stakeholders never were part of that old process. So there's work to do there as well.
And what about forest fire? Because we have been talking about forest fire in some of these talks, and sometimes it's used as a way to create these disturbances to create regeneration. So I don't know, maybe it's impossible with this 80% of humidity.
That's part of it. So one of the reasons I didn't talk about fire is that normally we don't think about fire in the Northeast U.S. This time of year it's too humid. Where I live, there's a burn season in the spring before the leaves come out, and there's another one in the fall when the leaves are shutting down. Otherwise you can't. So we often joke that the forests in the northeastern U.S. are an asbestos forest. It can't burn. Every once in a while, Mother Nature proves us wrong. In 1947, there were very large fires. Again, there was a lot more pine on the landscape that helped. With climate change, who knows? In our region, actually, the most important uses of fire are for conservation. We have quite a few species and we have specific forest types that are very fire dependent. Pitch pine, Pinus rigida, and many of the species that go with that. And so the Nature Conservancy has one of the largest fire crews around. The National Forest has a large fire crew, which they use to do a few things on our national forest, and then they send them, since I'm facing, send them west during the fire season, and then they come back. But private landowners have not really bought into fire. With climate change, we're supposed to get warmer and wetter on average. But of course, climate change also comes with variability. And so if we do see increase in cycles, periods of drought, as well as periods of excess precipitation. It doesn't take too much imagination to say, oh, we might well see more fire on the landscape. For some species, that will be good. For the people who suddenly find that their backyard is full of smoke, that will not be perceived well. In fact, that's a challenge for using prescribed fire, even where it's important for conservation, is smoke management with so many people. I love fire. It's great. It's good fun, but we don't get to play with it very much in our forests. Thank you all very much for coming. Thank you to those who are online, and I've enjoyed speaking to you today.